kids. Whoop, whoop. All right, so this is today's warm-up. Take a minute, look through it. It's just integer addition. And today's learning target is I will analyze axiomatic systems and identify types of geometry. Don't worry, it should be above in the comments on the paper. Well, let's talk about this warm-up. All right, pause for YouTube. This is just negative 12 plus 5 or negative 7. Positive negative makes negative, so negative 4. Minus 1 is just negative 5. Again, these make a negative. 12 minus 7 is 5. And negative 8 plus 11 is positive 3. Just want to make sure we have some practice on that integer addition. Here are these terms. I'm going to actually flash them up for you. Let's go right here. Take a minute. Pause. All right, so make sure and write these down. Undefined terms are just words that are formally explained by means of more basic words and concepts. We're giving you a lot of words for it's undefined, right? We don't know what it is. Postulate, a statement that is accepted as true without proof. That'd be like, I breathe oxygen. I don't need to prove it. I do. Theorem, a statement that can be proven using undefined terms, definitions, and postulates. Undefined terms, by the way, are also just variables. When we use variables to prove something, it means it works for all numbers because it works for a variable that stands in for all numbers. Synthetic geometry is the study of geometric figures without the use of coordinates, and analytic geometry is the study of geometry that uses the coordinate system. A lot of this, we're just defining parts of geometry. Pause this, write it down. We're going to move on with our day. I want to talk to you kind of about the flow chart of how it works. So first of all, if we have an undefined term, undefined terms, we see it kind of going right here. The first place it goes to is a definition. That means sometimes we're going to define those terms. Definition. I didn't give a lot of room, did I? Zoom in there a little bit, maybe pull this down so we don't see it. But also, an undefined term sometimes goes to an axiom or a postulate. Again, a postulate is something we accept without proof. It's accepted at face value. So we use undefined terms to help give our axioms or postulates. We use undefined terms to help fill in the definitions. We also use undefined terms to help us prove theorems. You'll notice this flowchart, sometimes we go from a definition to a theorem. Just from the definition of something, we can make theorems about it. Theorems are provable, are basically, I don't know, what was the definition we used? Theorems are statements that can be proven using undefined terms. So when we use the definitions, we can use those mixed with undefined terms to do theorems. Sometimes the definitions lead to just axiom and postulates, which are just facts, right? And again, we use a combination of these to get down to theorems. And we're going to be doing a lot of things called proofs. We'll be doing them with flowcharts. We're doing them with T-charts. And these proofs are going to be used to help show that certain mathematical truths are just true, such as the concept of anything plus 0 is itself, like 1 plus 0 is 1, 2 plus 0 is 2. Believe it or not, that's actually a rather lengthy proof. But today, I want to talk about applying how to apply an axiomatic system, which an axiomatic system is just a system of rules. And to do that, we're actually going to go to the site right here. This is the same thing you were seeing. It says, on the fictional planet Venus, scientists are categorizing species of flowers. Poisonous flowers have spots, while non-poisonous flowers have stripes. The scientists know that the shape of the flower depends on its environment. Okay? So it says poisonous flowers have spots. So if I look right here, we have poisonous, 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 and then non-poisonous have stripes. We see stripes, 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 non-poisonous, okay? But then over here, and this will be on your guided notes as well, we see a little thing telling us this shape of a flower likes a dry environment. So that would be the dragon rose, the feverfew flower. Those like a dry environment. Cold environments look like the spiny seedling or the velvety orchid. And then we have wet environments as the pokeweed and the weeping silkweed. Okay? So those are separated there. So let's look down here. This is on your paper as well. But we're going to drag something as being provable as accurate according to these laws, these axioms, these postulates. They're true. So it says the dragon rose grows best in an area that is at least 70 degrees. Well, let's look. Dragon rose is right here. It's poisonous. It's spotted. It does look like the one that likes dry, but here's the problem. Does dry tell us the temperature? No. So this is inaccurate. We have no idea if it likes 70 degrees or not. We just know it likes a dry place. The weeping silkweed grows in a wet environment and is poisonous. Well, let's look. Weeping silkweed, it's polka dotted, so it's poisonous. It looks like this, which matches the wet. So yes, it likes a wet environment and it's poisonous. That is accurate. The pokeweed grows only in fresh. In fact, why don't you take a minute, try to match the rest up. Pause me. I'll give you a breath. And then I'm going to keep going on. All right, now let's do it. The pokeweed grows only in fresh water. Let's see pokeweed. Pokeweed does like it wet, but does it say anything about fresh water? No, it might be salt water. We have no idea. So that would be inaccurate. How about the velvety orchid is poisonous only when ingested? Let's see. Velvety orchid is poisonous, but again, does it say anything about only being poisonous to eat, ingest it? No. That's inaccurate. That may be true, but we don't know. This axiomatic system, this system of rules where we know dry, cold, or wet, poisonous, non-poisonous, does not tell us that information. And then the spiny seedling is non-poisonous and lives in a cold environment. Let's see, spiny seedling. Where's that? Spiny seedling. It is non-poisonous because it's striped, and it looks like this, which is a cold environment. That would be accurate. Let's check our answers. Boom. So make sure you write those down on your guided notes. We're going to back here, and we're going to talk about the different types of geometry. Okay, we're going to talk about synthetic versus analytic geometry. Over here on the left, we have the synthetic. Notice that these are just shapes, no coordinates. Go ahead and write that down. It's also called pure or Euclidean geometry. So if you ever hear me say the words Euclidean geometry, I'm talking about no coordinates. We're just talking about the shapes themselves. That's why it's called pure geometry. Geometry is the study of shapes. Then we have analytic geometry. Now analytic geometry is over here. You'll notice it has coordinates. We still have the same shapes as over here, but now they have coordinates with x1, y1, b is x2, y1. So it's just the coordinates of each of those points. And we start dealing with what are the coordinates doing. So this one uses coordinates. And it's called coordinate or Cartesian geometry. And this geometry was actually built as a bridge to connect geometry with algebra. I've talked about that a little bit before with coordinates. So I want to go down here, and let's just take a minute, and I want you to use those definitions and classify each of these. Ready, set, go. All right? So hopefully you saw this was a pretty simple thing to do. What is it? This is simply synthetic. There's no coordinates. This is analytic. There are coordinates. It's really that easy. And down here is also analytic geometry. And last, we have synthetic geometry. Believe it or not, this is our intro to geometry, and it's really supposed to be fairly simple. So you've got some homework problems. They do get a little more challenging, especially with the axiomatic systems, but go ahead, check them out. And with that said, peace out.